Good morning, students. Dear students, as in the previous video, we have discussed chapter 5, Law of Motion, part 8, and in that video, we had discussed about the equilibrium of forces. We had discussed about equilibrium of forces. Equilibrium of forces. Yes, students, while discussing about equilibrium of forces, we had discussed two type of cases, and in the first case we had discussed that if there are two concurrent forces F1 and F2, and these two forces are acting at a point O, and if they are equal and opposite, then the resultant force of these two concurrent forces, resultant force F resultant that is equal to F1 plus F2, and it is equal to 0. So net force at point A due to the effect of F1 and F2 is 0. So the point O is said to be in equilibrium under the effect of forces F1 and F2. So it is, in this case we had taken the two forces. Another case we had taken three forces, three concurrent forces we had taken, that is F1, F2 and F3, and we had supposed that the resultant of the forces F1 and F2, the resultant of the forces F1 and F2 is resultant of force F1 and F2 is equal and opposite to the force F3 in such a way that F1 plus F2 plus, because F1 is overruled by writing down, you can write it as F1 plus F2. So F1 plus F2 plus F3 is equal to 0. So we had said that if these forces are acting at point A, then these forces are acting at point O, then the point O is in equilibrium under the effect of forces F1, F2 and F3, and so we can say that F1 plus F2 plus F3 is equal to 0. Now today we will going to discuss about the application of equilibrium of forces, and the application of equilibrium. Only one topic today we will discuss, that is application of equilibrium of forces, that is Lami's theorem, and we will discuss about Lami's theorem, then proof of Lami's theorem, and one numerical based on Lami's theorem. This is all for today. So let us discuss about Lami's theorem. We will discuss about Lami's theorem. Look here, students. Lami's theorem. And this Lami's theorem states that according to this theorem, according to this theorem, when three concurrent forces what are the forces? F1, F2 and F3. F1, F2 and F3 active on a body in equilibrium. Means if three forces forces F1, F2 and F3 is acting on a body in equilibrium in such a way. Suppose this is body O and this is F1, this is F2 and this is F3. These three forces are acting on a body in equilibrium. Then suppose this angle is alpha, this angle is beta and this angle is gamma. Means the angle between F1 and F2 and F2 and F3. F1 and F, this is F3. So if the forces F1, F2 and F3 is acting on a body which is at point A, and all these forces are inclined to each other with an angle alpha, beta and gamma, then according to, first of all, I elaborate you about the angles. Alpha is the angle between forces F1 and F3. Beta is the angle between forces F2 and F3, and gamma is the angle between forces F1 and F2. Gamma is the angle between the forces. So these are the angle between the forces F1, F2 and F3. So we can say that according to Lami's theorem, we can say that F1 upon sine beta. F1 upon sine beta is equal to just opposite angle. F2 upon sine alpha, or for convenience you can suppose this angle is F1, F2 and F3. So for convenience you can suppose that F1 upon this angle is alpha, F2 this angle is beta, and F3 this angle is gamma, because the sequence is maintained alpha, beta and gamma. Clear? So alpha is the angle between F2 and F3. Alpha is the angle between F2 and F3. Beta is the angle between F1 and F3. And gamma is the angle between F2 and F1 and F2. So we can write as F1 upon sine alpha, F1 upon sine alpha, F2 upon sine beta, and F3 upon sine gamma. This is the relation according to F1, F2 and F3. This is the relation between F1, F2 and F3 according to Lami's theorem. So in nutshell I am describing it again. According to this theorem, when three concurrent forces, all F1, F2 and F3 are concurrent forces acting on a body placed at point O, these forces are acting on a body, this body is in equilibrium under the effect of these forces, then according to Lami's theorem, we can write F1 upon sine alpha equal to F2 upon sine beta is equal to F3 upon sine gamma, where alpha is the angle between F2 and F3, beta is the angle between F1 and F3, and gamma is the angle between F1 and F2. So this is all about Lami's. Now we will go for the proof for Lami's here. We will go for proof for Lami's. Now here is the proof for Lami's theorem. For this, I am drawing a figure. Suppose this is a triangle, and this triangle is represented by A, B, and C. This triangle is represented by. Now we are going to extend each of the side of the triangle. And we have marked the forces F1, F2 and F1, F2 and F3. Now if the angle between F1 and F2, suppose this angle is gamma, then angle between F1 and F3, this is the direction of force. Why we have drawn this? Because we have discussed in the previous video, if there are three concurrent forces, F1, F2 and F3, F1, F2 and this is F1, this is F2 and this is F3, and they are in equilibrium. So if they are in equilibrium, alpha, beta and gamma, alpha, beta and gamma. And if they are in equilibrium, F1, F2 and F3 are in equilibrium, then they can be represented by the both sides of the triangle taken in the same order. So if we have drawn this as F1, we have drawn this side as F2, then we have drawn this side as F3, and we have represented this for these forces which are in equilibrium with the closed side of the triangle. Now look at here, F1 is in this direction and F2 is in this direction. So the angle between F1 and F2 is gamma. Now the angle between F2, this is F2 and this is F3. The angle between F2 and F3. Angle between F2 and F3 is beta. This angle is beta. Now angle between F1 and F3. Angle between F1 and F3. So this angle is alpha. This angle is alpha. Look at here. We have drawn this diagram. We have drawn this diagram equivalent to this diagram. Again, I am saying, okay, this is suppose this is point O, and this point O is in equilibrium under the force F1, F2 and F3. Then it can be represented by the closed triangle. It can be represented by the closed triangle in which all the forces that are vector forces which can be represented by the closed side of the triangle. So we have taken it as A, B, AB is the vector representing force F1, BC is the factor which is representing force F2, and C is the vector which is representing force F3. Now we have represented this figure with the closed side of the triangle. Now we have to represent the angles between these forces. So look at here in the diagram, the angle between F1 and F2, the angle between F1 and F2. F1 is this force and F2 is this force. The angle between F1 and F2 is alpha, F1 and F2 is gamma. The angle between F1 and F2 is gamma. The angle between F2 and F3, the angle between F2 and F3 is beta. And the angle between F3 and F1, the angle between F3 and F1 is alpha. Clear, students? Now look at here. Look at here. This is a straight line, and these angles are supplementary angles. Supplementary angles. So we can write this angle as pi minus alpha. We can write this angle as pi minus beta, and we can write this angle as pi minus gamma. We can write this angle as pi minus gamma. So angle CAB is equal to pi minus alpha, angle ABC is equal to pi minus gamma, and angle BCA is equal to pi minus beta. Now we are going to apply the law of sine here. We are going to apply the law of sine. According to the law of sine, triangle ABC. I'm writing here. Since forces F1, F2 and F3 are in equilibrium under the effect of F1, F2 and F3 are in equilibrium. Then these forces can be represented by the sides of a triangle taking same order. Then they can be represented. Now, according to law of sine, you will study it. Dear students, you will study about law of sine and law of cosines in mathematics, also in the chapter triangles. So I am talking about just for application based and talking about. So you can write here as this angle is pi minus alpha. So and this angle is pi minus alpha. This angle is F1. F1 sine pi minus F1 opposite angle is F1 sine pi minus b. F1 sine pi minus beta is equal to F2 sine pi minus alpha is equal to F3 sine phi minus gamma, and you can write it as F1 sine beta is equal to F2 sine alpha equal to F3 sine gamma. F3 sine, because sine pi minus theta is equal to sine pi minus theta is equal to sine pi minus theta is equal to sine theta. So this is the proof for Lami's theorem. This is the proof for Lami's theorem. Now, dear students, we will discuss one numerical based on this. Now, dear students, look at the numerical which is based on Lami's theorem, and this numerical is in front of you. What is the numerical saying that? In the figure below, this is the figure given to you, which is in the form of quadrilateral. Part of the horizontal stress net, it is just like a net, horizontal net. The net is stressed like this. Section AB is stressed. This is section AB. This force, this section AB. Section AB is stressed with the force of 10. A force of 10 Newton is applied here, and this force of 10 Newton, the section AB is stressed. Then you have to determine the forces in section BC and BF. We have to determine the forces in section BC and BF. Means if we suppose this force is F1 and this force is F2, then we have to find the value of F1 and F2 based on Lami's theorem. So first of all, we will draw the free body diagram at point B. Drawing free body diagram. Free body diagram at point B. We will draw free body diagram at point B. So we are considering here, this is point B, and this is A, and BA is of 10 Newton. Now BC and BF. This is BC, where force F1 is acting, and this is BF, where force F2 is acting, and the angle is given between F1 and 10 Newton is 120 degree. This angle is 120 degree. So 120, 120, and at that point there are the complete angle is 360. So 360 minus 240. 360 minus, then it is obviously of 120 degree. Now, in section BC, suppose let forces in section BC F1 and section BF is equal to F. BC, the force is F1, and BF, this is force F2. Now applying Lami's theorem here. Applying Lami's theorem. Applying Lami's theorem here. So F1 and the angle opposite to this, F1 upon sine 120 degree is equal to F2 upon sine 180 degree. F2 upon sine 120 degree is equal to 10 Newton. This force is 10 Newton. 10 upon sine 120. This is according to Lami's theorem. F1 upon sine 180 degree, F2 upon sine 180 degree, and 10 upon sine 180 degree. Now these all are going to be cancelled it out, and we can say that F1 is equal to F2 is equal to 10 Newton. Means both the forces are of 10 Newton. Both the forces are of 10. So, dear students, that's all for today's video. And now, in the next good video, we will discuss about some common forces in mechanics, and after that, I will discuss about some certain free body diagrams, and we will solve 2 or 3 numericals based on this, on that in the next video. So, that's all for today's students. Thank you. Have a nice day. Take care.